The National Electrical Code (NEC) provides specific requirements for hazardous classified locations, particularly relevant to battery rooms where sulfuric acid wet cell batteries are present. Article 503 addresses hazardous classified locations, Class 1, outlining crucial safety measures. Section 503.3 A1 requires explosion-proof equipment in areas where flammable liquids, gases, or vapors exist in sufficient quantities to create explosive or ignitable mixtures. Section 503.9 specifies that electrical equipment must be listed for Class 1, Division 1 locations when hazardous concentrations of flammable substances may be present at all times during normal operating conditions. Section 503.12 mandates ventilation systems to prevent the accumulation of flammable vapors or gases. To ensure safety in a battery room with 192 sulfuric acid wet cell batteries, several measures should be implemented. Firstly, install a forced air ventilation system to continuously remove hydrogen gas produced by the batteries. Hydrogen is a flammable gas, and its accumulation can create an explosion hazard. Secondly, utilize explosion-proof lighting fixtures throughout the battery room. Standard lighting fixtures can produce sparks that could ignite flammable gases. Thirdly, strictly prohibit smoking within the battery room. Smoking materials can easily ignite hydrogen gas or other flammable vapors. Fourthly, ensure that flammable liquids and gases are stored away from the battery room. This minimizes the risk of these substances contributing to an explosion. Fifthly, conduct regular inspections and maintenance to ensure all equipment is in proper working order. This includes the ventilation system, lighting fixtures, and the batteries themselves. Sixthly, provide comprehensive training to all personnel on safety procedures and emergency response plans. This ensures that employees are aware of the hazards and know how to respond in an emergency. In addition to the NEC requirements, several industry publications offer valuable insights into battery room safety. Industrial Safety and Hygiene News features an article titled Explosion Prevention in Battery Rooms, which provides detailed guidance on mitigating explosion risks. Occupational Health and Safety (ONS) offers an article called Battery Room Safety Preventing Explosions, focusing on preventive measures. Valve magazine includes an article on explosion protection for battery rooms, discussing specific protection strategies. When implementing an emergency response plan, include procedures for evacuation, fire suppression, and medical assistance. Ensure that the plan is well communicated and regularly practiced. It is critical to follow NEC guidelines to create a safe and protected battery room, specifically Article 503.3. A1, which mandates explosion-proof equipment where flammable substances are present, and Article 503.9. A, which requires equipment listed for Class 1, Division 1 locations under normal operating conditions. Section 503.12 is also critical for ventilation, while maintaining a strong focus on safety protocols is a must. When considering ventilation systems, calculating the necessary air changes per hour is crucial to effectively remove hydrogen gas. The rate of hydrogen generation depends on the number and type of batteries, as well as their charging regime. Consult industry standards and engineering guidelines to determine the appropriate ventilation rate. Ensure the ventilation system is designed to prevent dead zones where hydrogen gas could accumulate. Explosion-proof lighting fixtures must be certified for Class 1, Division 1 locations. These fixtures are designed to contain any internal explosion, preventing it from propagating to the surrounding atmosphere. Regularly inspect these fixtures for any signs of damage or deterioration. When storing chemicals, maintain a safe distance between flammable materials and the battery room. Use proper storage containers and follow all applicable regulations for the handling and storage of hazardous materials. Document all inspections, maintenance activities, and training sessions. This documentation provides a record of compliance and helps identify potential issues before they become major problems. Regularly review and update the emergency response plan to ensure it remains effective and relevant. Conduct periodic drills to test the plan and identify areas for improvement. Consider installing hydrogen detectors in the battery room. These detectors can provide an early warning of hydrogen gas accumulation, allowing personnel to take corrective action before an explosive atmosphere develops. Ensure the detectors are properly calibrated and maintained. Ground all electrical equipment in the battery room to prevent static electricity buildup, which could be a source of ignition. Regularly inspect grounding connections to ensure they are secure and effective. Use non-sparking tools in the battery room to minimize the risk of ignition. Conduct a hazard assessment to identify all potential hazards in the battery room and develop appropriate control measures. The hazard assessment should be reviewed and updated regularly. Implement a lockout-tagout program to ensure that equipment is properly de-energized before maintenance or repairs are performed. Provide employees with personal protective equipment, PPE, such as safety glasses, gloves, and aprons to protect them from battery acid and other hazards. The selection of equipment for use in a hazardous location is a crucial part of ensuring safety. Understanding the different classes, divisions, and groups within the NEC is essential for selecting the correct equipment. Class 1 locations involve flammable gases or vapors. Division 1 indicates that the hazardous material is present under normal operating conditions. Equipment must be specifically designed and certified for these conditions. Explosion-proof enclosures are designed to contain an internal explosion and prevent it from igniting the surrounding atmosphere. Intrinsically safe circuits limit the energy available to a level that cannot cause ignition. Purged and pressurized systems maintain a clean, inert atmosphere within an enclosure to prevent flammable materials from entering. Regularly inspect all explosion-proof equipment to ensure it is in good working order. Check for any signs of damage, corrosion, or loose connections. Ensure that all seals and gaskets are intact and properly installed. Any modifications or repairs to explosion-proof equipment must be performed by qualified personnel using approved parts and procedures. Maintain detailed records of all inspections, maintenance, and repairs. In addition to the NEC, other standards and guidelines may be relevant to battery room safety. The Institute of Electrical and Electronics Engineers, IEE, provides standards for electrical safety and design. The National Fire Protection Association, NFPA, publishes codes and standards related to fire protection and safety. The Occupational Safety and Health Administration, OSHA, sets regulations for workplace safety. Stay informed about the latest standards and regulations to ensure compliance. Regularly review and update safety procedures and training programs. Encourage employees to report any safety concerns or near misses. Foster a culture of safety in the workplace. Consider the specific characteristics of the batteries when designing the ventilation system. Valve-regulated lead-acid (VRLA) batteries produce less hydrogen gas than flooded lead-acid batteries. Lithium-ion batteries have different safety considerations and may require different ventilation and fire suppression systems. Consult with battery manufacturers and industry experts to determine the appropriate safety measures for the specific type of batteries used. When selecting a location for the battery room, consider factors such as proximity to other buildings, potential sources of ignition, and access for emergency responders. Locate the battery room in a well-ventilated area away from potential sources of ignition. Provide adequate access for emergency responders in case of a fire or other emergency. Consider the environmental impact of the battery room. Implement measures to prevent spills and leaks of battery acid. Properly dispose of used batteries and other hazardous materials. Implement a comprehensive safety management system that includes policies, procedures, training, and audits. Regularly review and update the safety management system to ensure it remains effective. Consider using remote monitoring systems to track battery voltage, temperature, and other parameters. These systems can provide early warning of potential problems. Implement a fire suppression system in the battery room. The type of fire suppression system should be appropriate for the type of batteries used. Train employees on how to use the fire suppression system. Regularly inspect and maintain the fire suppression system. Implement a spill containment system to prevent battery acid from spreading in the event of a spill. Provide employees with spill response training and equipment. Regularly inspect and maintain the spill containment system. Consider the security of the battery room. Implement measures to prevent unauthorized access. Monitor the battery room for signs of intrusion. Regularly review and update security procedures. Implement a change management process to ensure that any changes to the battery room or its equipment are properly evaluated and approved. Regularly review and update the change management process. Implement a continuous improvement program to identify and implement opportunities to improve safety performance. Regularly review and update the continuous improvement program. Share safety information and best practices with other organizations. Participate in industry safety groups and conferences. Stay informed about the latest safety technologies and techniques. Consider the use of automation to reduce the risk of human error. Automate tasks such as battery charging, washing, and maintenance. Use robots to perform hazardous tasks such as battery replacement. Implement a data analytics system to track safety performance and identify trends. Use data analytics to identify areas for improvement. Implement a predictive maintenance program to anticipate and prevent equipment failures. Use sensors to monitor equipment condition and performance. Use machine learning algorithms to predict when equipment is likely to fail. Consider the use of virtual reality, VR, or augmented reality, AR, to train employees on safety procedures. Use VR or AR to simulate hazardous situations and provide realistic training. Use VR or AR to provide remote assistance to employees performing maintenance or repairs. Implement a mobile safety app to provide employees with access to safety information and tools. Use the mobile app to report safety concerns and near misses. Use the mobile app to track safety performance and provide feedback to employees. Consider the use of drones to inspect battery rooms and equipment. Use drones to inspect hard-to-reach areas. Use drones to monitor battery room conditions. Implement a digital twin of the battery room to simulate and analyze safety performance. Use the digital twin to test different safety scenarios. Use the digital twin to optimize battery room design and operations. Consider the use of artificial intelligence, AI, to improve safety performance. Use AI to analyze safety data and identify patterns. Use AI to predict and prevent accidents. Use AI to optimize safety procedures and training programs. Remember that safety is an ongoing process that requires continuous attention and improvement. By implementing these measures, you can create a safer battery room environment and reduce the risk of accidents. The key to ensuring a safe battery room is a combination of proper design, adherence to safety standards, regular inspections, and employee training. By implementing these measures, you can significantly reduce the risk of explosions and other hazards.